covalent bond. Okay, what is a covalent bond? So, in covalent bonding, sharing of electrons will happen. So, if we look about a hydrogen atom, so each hydrogen atom, it have a positive nucleus. Okay, as you know that hydrogen, its atomic number is 1. Okay, so both nuclei, if you have to make a H2 gas, it can be made by hydrogen and hydrogen. Now the atomic number of hydrogen is 1. That means it have only one electron, which I am representing by a dot. This hydrogen, it is also having one electron in its nucleus. So I am representing it by a cross. Okay. Now, what happens to achieve stability? All the other elements, they want 8 electrons in their outermost shell to become stable. But for hydrogen and helium, there are 2 elements which require only 2 electrons to achieve stability. So what happened that this hydrogen, it will share its one electron with this electron of other hydrogen, and this hydrogen, it will share one electron from this hydrogen. Now this hydrogen also have 2 electrons stable, and this hydrogen also have 2 electrons which is stable. So what it is written here that each hydrogen atom, it has a positive nucleus. Both nuclei attract the shared electrons. Shared means because this electron, it belongs to this hydrogen, but it is shared with this second hydrogen also, right? So this strong force of attraction, it holds the 2 atoms together. So these 2 electrons make a bond like this. So we have H2 molecule. And this attraction is called covalent bond. So covalent bond is formed by sharing of electrons. So remember, compare it with the ionic bond. In ionic bond, we have learned for sodium chloride that sodium, it is losing its one electron completely and it is becoming Na+1. Similarly, chlorine, it is gaining its one electron which sodium lost to form NaCl-, right? So in ionic bond, you have a transfer of electrons, complete transfer of electrons. But in the covalent bond, you have the sharing of electrons. So here in H2, you have a single covalent bond which is formed when 2 atoms share 2 electrons. Okay, so when 2 atoms, hydrogen and hydrogen shares 2 electrons, it form a single covalent bond. Is it clear? Any doubt? Am I audible? Am I audible? Turn on your video.
Ma'am, can you hear me?
Yeah, I can hear you.
Sorry, my network is really bad. Could you please repeat what you're saying?
Okay. So we are discussing about the covalent bond. In covalent bond, sharing of electron will happen. Okay, for example, look at this hydrogen, H2. You have to make this H2 gas. So this is my first hydrogen, this is my second hydrogen atom. Now you know that hydrogen, it have only one electron, right? Its proton number is only one. This hydrogen is also having one electron. I am representing it by a cross. Now, to achieve stability, all the other elements, they want 8 electron, right? We discussed in the ionic bond. But there are two elements, hydrogen and helium, which require only 2 electrons to become stable. So this hydrogen, it will share its one electron with this hydrogen, and this second one, it will share its electron with this hydrogen. And after sharing both the electrons, a single covalent bond is formed. So a single covalent bond, it is formed when atoms share 2 electrons. Okay, so this force of attraction which exists between this H2 molecule, it is called a covalent bond. So remember the ionic bond. In ionic bond, your transfer of electrons is happening, where sodium is completely losing its one electron and chlorine is completely gaining the electron. No sharing will happen. No sharing of electrons is happening in your ionic bond. But in covalent bond, both the atoms they share its electron to achieve stability. Is it clear?
Yes, ma'am.
Okay, so you want to write it down?
Yes, ma'am.
Okay, write it down. Once done, please let me know. See, we have two hydrogen atoms, this one and this one. This is the electron for this hydrogen atom, which is represented as dot. It is represented as a cross. So sharing of electron will happen. It is a shared pair of electron, and this is a covalent bonding in H2 molecule. Draw this covalent bonding. Both are stable because I told you that hydrogen and helium, they require only two electrons to become stable. Okay,
Yes.
it draws this covalent bonding. We have learned how to make ionic bonding. Now learn to make covalent.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done.
Not yet.
You can ask for the hard copy of the soft copy of the notes from the respective WhatsApp group of this chapter. Have you got it?
Yes.
Okay.
I'm done.
Now molecules. What are molecules? So this H2 is known as a molecule. The two bonded hydrogen atoms above, we have made the covalent bonding in H2. So it forms a molecule of hydrogen. So basically its definition is that it is a group of atoms which are held together by covalent bonds, right? So many other non-metals are also molecular. For example, iodine. This is also a molecule. I2 is also a molecule. Oxygen is also a molecule, O2. Nitrogen, chlorine, sulfur, phosphorus, all are molecules. Now, what is a diatomic? So, as the name suggests, di means two. So, elements which are made up of molecules containing two atoms, they are called diatomic. For example, O2, it is made up of two atoms, right? Two oxygen atoms. So, it is called as diatomic. Cl2, It is made up of two atoms of chlorine, so it is called as diatomic. Okay, H2 is also called as diatomic because it is made from two hydrogen atoms. Okay, so if we want to draw the covalent bonding in oxygen, how can we draw the covalent bonding in oxygen? We'll read it next slide. So now you have to remember what is a molecule. It is a group of atoms which are held together by covalent bonds. Examples of molecules are given here. They are non-metals, iodine, oxygen, nitrogen, chlorine. All are non-metals, they are molecules. And what is diatomic, which are made up of from two atoms, is called diatomic. Okay, elements made up of molecules containing two atoms are called diatomic. Is it clear?
Yes, ma'am.
Write it down. Now see how to write down the covalent bonding, how to show the covalent bonding in chlorine. Okay, so first of all you have to see the valence electrons of chlorine. So its atomic number is 17, its configuration would be 2, 8, 7. So there are 7 valence electrons, that means outermost electrons in chlorine. 1, 2, 3, 4, 5, 6, 7. Here also we have made 7 valence electrons of chlorine. Here you have represented it by a dot to clearly depict, and here you have represented it by a cross. Now to show the covalent bonding in chlorine, chlorine needs 8 electrons to achieve stability. So what happens? These electrons are shared by both the chlorine atoms. Now this also have 8 electrons in its outermost shell. You can count 1, 2, 3, 4, 5, 6, 7, 8, and this chlorine also have 8 electrons in its outermost shell. So these are my 2 chlorine atoms, and now it is a chlorine molecule. How many pairs of electrons are shared? Pair of electrons means 2 electrons. Okay, because it is a pair. So only one pair of electron is shared. So bond is called the single covalent bond. Okay, single bond. So we write it like this: chlorine, single bond, and chlorine. So it is the covalent bonding in chlorine. Any doubt in this?
No, ma'am.
Okay, so draw the covalent bonding in chlorine.
Done.
Okay. Now the covalent bonding in oxygen. So covalent bonding in oxygen is made by, first of all, write down the atomic number. It's 8. Then write down the electronic configuration. It is 2, 6. Now there are 6 electrons, valence electrons. So you have to show 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. Right. Now both the oxygen atoms need 2 electrons to achieve stability, right? To complete it to 8 electrons. So they share 2 electrons. 2 shared pair of electrons are there. 2 shared pair means there are total 4 electrons which are shared. You can count 1, 2, 3, and 4. Since the oxygen atoms share 2 pair of electrons, the bond is called a double bond. So whenever you write the bond of oxygen, then you will write it like a O2, double bond. So this is correct. If you write this, then this is incorrect. Because in this, there are only 2 electrons which are shared, and in this, you have 4 electrons which are shared. And the 4 electrons is correct because 2 electrons, because 2 electrons are shared by this oxygen with this oxygen, and similarly, this oxygen also shares its 2 electrons with the another oxygen atom. So O double bond O is correct and O single bond O is not correct. Clear? Any doubt in this covalent bonding in oxygen?
No, ma'am.
So draw covalent bonding of oxygen in your notebook.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
5. Right. Now they need how many more electrons to achieve stability? 3 electrons, right? To complete it to 8. So they share 3 pairs of electrons. This nitrogen, it will share 3 electrons with this nitrogen, and this shares 3 electrons with this nitrogen. So you can write it like this: 1, 2, 3, 4, 5, and this nitrogen 1, 2, 3, 4, 5, right? Now, one is your this kind of bonding, and one is your this kind of bonding. So both these nitrogen atoms now have 8 electrons. 1, 2, 3, 4, 5 of itself, and 3 has been shared from the another nitrogen. So this also becomes now 8 electrons, and this also becomes 8 electrons after sharing. So the nitrogen atoms, they share 3 pairs of electrons. That is why it is called a triple bond. And you have to represent it like this. That means how many electrons are shared? 6. 1, 2, 3, 4, 5, and 6. And how many pairs of electrons are shared? So you have to write 3. Okay?
Yes.
We'll draw the covalent bonding in nitrogen. Done?
Yes.